right, so let's look at finding the volume when you take an area, and so in this case it would be this area between the curve, between the y-axis, y equals x squared, and then y equals 5. And we're going to take that area that I kind of shaded, we're going to revolve it around the y-axis. So that means that this thing is going to look, kind of like this, but three-dimensional. So one way of finding the volume is to divide the shape into little discs, and each one of them has an area of a volume of dV. And this time, when we're thinking about the disc, it's going to look like this, and then it has some height to it, and it has some radius. Oh, it wasn't easy to see that radius. So the thickness of this is going to be, you can see it's in the y direction, so it's dy. But if you think about just the volume of a disk, it's the area of the surface, which is pi r squared, and then times the height. Now when we're taking these small pieces, the height in this particular example is dy, and then we have the pi r squared. So then we have to figure out, well, what variable describes the radius? And when I'm looking at this picture, the value of the radius right here, that's going to be actually the x. So that's pi x squared, and then times dy. And this is what I'm going to integrate. Now, I have to, this dy tells me that y is my variable of integration, and I'm going to integrate from 0 to 5, because that's where the top of this is. And this means I have to write x in terms of y in order to be able to do the integration. And so that's how I'm going to be able to find that volume. So the general idea is that it's going to be pi r squared times the thickness of the disk. It's a matter of trying to figure out how do I write the radius in terms of my shapes, and then do the integration. Just really quickly, if I had the case where I maybe took this curve and I revolved around the x-axis, and say I went to x equals 4, then now my disk is going to be oriented differently, right? And so the thickness or the height of my disk in this case is going to be dx, but my radius is going to look like a y value. So when I'm finding my volume, it's pi r squared times dx, but the radius is actually y squared. Radius squared is y squared, and I'm going to have to write this in terms of x in order to do my integration. And for this particular problem, I would go from 0 to 4 because of the way I set it up. It's going to stop right here at x equals 4. Now, one more thing I want to show you about the disks is the idea of what if I have a shape that really kind of has like a hole in it. So what if I did something like x equals y, but then I had a y equals x squared, and I revolve around the y-axis. So then you're going to have basically the shape that has a hole in it. So it's going to be sort of this shape would define the outer disk, and then this line would define the inner disk. And your total volume would be pi r outer squared times dy, and then you have to subtract pi r inner times dy squared. So you basically are going to be finding the area of the outer disk minus, not the area of the outer disk, the volume of the outer disk minus the volume of the inner disk. Keeping in mind that you can't just subtract your radius. You can't do r outer minus r inner and square that. That's not going to work. You have to do it like this. All right, so hopefully that helps for disks. And next time I'll do shells.